we will talk about heat and temperature, which in physics we call this as thermodynamics. Okay, so thermodynamics, the heat and temperature. So, what are the objectives for today's topic? So, we have here the following objectives for today's topic. So, first, we will differentiate temperature and heat, then convert temperature reading from one scale to another scale. Next is to describe a material based on its coefficient of thermal expansion, and solve problems involving thermal expansion, and last is to perform experiments related to thermal expansion. So these are the objectives that we wanted to attain at the end of this topic. So first, let us proceed first with differentiating temperature and heat. So what is the difference between temperature and heat? So ano ba yung pinagkaiba ng temperature at ng heat? So if we say temperature, okay, so temperature, it is a way of describing how hot or cold an object is. Okay, it is a way of describing how hot or cold an object is. And usually or commonly, it is measured by degree Celsius. Okay, so temperature, it is a way of describing how hot or cold an object is and is measured in degree Celsius. So commonly, temperature can be obtained through apparatus such as thermometer or thermoscanner. Okay, so just like what is happening today during this pandemic. So you'll know that if we enter an establishment or anywhere we go, okay, the personnel in charge will take our temperature by using a thermometer or a thermoscanner. So we say that they are taking our temperature, so they wanted to know if we are hot or we are cold. So kasi if our temperature is very high, then it means that we are hot and we are having a fever. So if we are if we have a high temperature, so we are hot and we are having a fever. So that's why they are getting our temperatures. So that is the temperature. So it is describing, so a way of describing how hot or cold an object is, and usually it is measured in degree Celsius. Okay, but the unit, okay, or the measurement that is being used in temperature is not only limited to degrees Celsius. There are some other scale, just like degree Celsius. So there are other some scale which is used to measure the temperature of a certain object or a certain person. But commonly, especially here in the Philippines, we are using the degree Celsius or the Celsius scale. Okay, so that's for temperature. So how about heat? Okay, if temperature is describing how hot or cold an object, how about heat? So when we say heat, okay, heat is a form of energy. Okay, heat is a form of energy. It is also known as the thermal energy. It is a form of energy. In Wikipedia, if we search temperature and heat, okay, the meaning of temperature in Wikipedia is the average kinetic energy of the molecules of a substance. And ang heat naman, it is an energy in transit due to temperature difference. And energy, or the energy that is produced, okay, is what we call the heat. So it is produced by the, or through the movement in molecules. Okay, so by the movement of molecules, okay, by the movement of molecules, an energy is produced, and that is what we call as the heat, or the thermal energy. Okay, so, and the average of that, movement, or what we call the kinetic energy of the molecules, is what we call as the temperature. Okay, so that is the difference of temperature and heat. Okay, so yung sinasabi ko kanina, the temperature is not only limited to degree Celsius. So hindi lang degree Celsius ang ginagamit natin in describing the temperature of an object. So there are some other scales which is being used in describing the temperature of an object. And these are, okay, so these are the scales that is being used in describing the temperature of an object. So first we have the Celsius scale, and we also have the Kelvin scale, the Fahrenheit scale, and the Rankine scale. So I think among the four, the Celsius and the Fahrenheit is the one that is very familiar with us. Okay, so I think we are familiar with Celsius and Fahrenheit. And for Kelvin and Rankine, so I don't know if you happen to hear this type of scale in temperature. So if not, then these are the four scales that is used in describing the temperature of an object. So let's start first with the Celsius scale. So since ito yung pinaka-common sa atin, okay, so let's start first with the Celsius scale. So Celsius scale is developed by Sir Anders Celsius. Okay, so it is developed by Sir Anders Celsius during 1948. Okay, so he developed the Celsius scale during 1948. So Celsius scale, if we will identify, or if we base it on water, so if we base it on water, okay, if the Celsius scale is based on water, so the freezing point, okay, the freezing point of water is equal to 0 degree Celsius. Okay, so the freezing point of water, if we base it on Celsius scale, is 0 degree Celsius. Okay, 0 degrees Celsius, that doesn't mean that since it is 0 degrees Celsius, since it is 0, that doesn't mean na wala siyang temperature. But in Celsius scale, 0 degrees Celsius means a very, very cold temperature. So it is a very, very cold temperature. So since 0 degrees Celsius, it is the freezing point of a water. At a temperature of 0 degrees Celsius, yung tubig ay maninigas, and it can produce ice. Okay? So that doesn't mean that 0 siya, then it means wala siyang temperature. But 0 degrees Celsius, it means that it is a very, very cold temperature. Okay? The next is the boiling point of water, which is 100 degrees Celsius. So 100 degrees Celsius, it is the boiling point of water. And one thing that is somehow very in Celsius scale is that Celsius scale is used, it is commonly used by most of the world, especially in the Europe and in Asia. So we are using the Celsius scale. So that's why Celsius scale is very familiar with us, especially for us Asian, since it is commonly used in Europe and in Asia. Okay, so Celsius scale is used by most of the world, especially in Europe and in Asia. Okay, so that is for the first scale, which is the Celsius scale. The second scale is what we call as the Fahrenheit scale. So the Fahrenheit scale is developed by Sir Daniel Gabriel Fahrenheit during 1724. So Sir Daniel Gabriel Fahrenheit developed the Fahrenheit scale during 1724. So just like Celsius scale, the 0 degree Fahrenheit doesn't mean that it has no temperature, but rather 0 degree Fahrenheit means a very, very cold temperature. So since if we based it on water, if kanina 0 degree is yung freezing point ng water when it comes to Celsius, in Fahrenheit, the freezing point of water is only 32 degree Fahrenheit. So at 32 degree Fahrenheit, maninigas na yung tubig at it can produce an ice. Okay? So that is the freezing point of water on Fahrenheit scale. So for the boiling point naman, we have the 212 degree Fahrenheit as the boiling point of water. So ito yung freezing point at boiling point ng water. So it is the same with Celsius. Okay, so it is the same with Celsius that when we say that 0 degree, so it doesn't mean na wala siyang temperature, but it has a different meaning, which means that it is a very, very low temperature. Okay, so that is for the Fahrenheit scale. And one thing that is different from Fahrenheit to Celsius is that Fahrenheit scale is commonly used in America. Okay, so Fahrenheit scale is commonly used in America. So if kanina, Celsius scale is commonly used in Europe and in Asia, so Fahrenheit scale is commonly used in America. Okay, so that is the second scale of temperature, which is the Fahrenheit scale. So the third scale, which is the Kelvin scale, okay, the Kelvin scale, which was developed by Sir William Thomson, or also known as the first Baron Kelvin during 1848. Okay, so this is the third scale, yung third scale, which was developed by Sir William Thomson, or also known as the first Baron Kelvin. So during 1848, okay. So unlike Celsius and Fahrenheit, the Kelvin scale is based on absolute zero. Okay, so Kelvin scale is based on absolute zero and intertwined with the idea of kinetic energy. So what does it mean when we say it is based on absolute zero? Okay, so when we say based on absolute zero, it is different from Celsius and Fahrenheit. So since Celsius and Fahrenheit, 0 degree Celsius and 0 degree Fahrenheit, that doesn't mean na wala siyang temperature, but it has a different meaning which means that it is a very, very cold temperature. In Kelvin scale, okay, in Kelvin scale, 0 Kelvin, okay, so 0 Kelvin means no temperature, okay, so 0 Kelvin means no temperature. So, 0 yung kanyang temperature. So, wala siyang temperature. That is the difference between Kelvin and Celsius and Fahrenheit. So, since it is based on absolute zero, so 0 Kelvin means no temperature. So, since it is intertwined with the idea of kinetic energy, so if we say zero kinetic energy, then therefore there is no movement, di ba? So when we say zero kinetic energy, then there is no movement. So it is also the same with 0 Kelvin. So it means that there is no temperature because the temperature at which all the motion stops, or the absolute zero, referred as 0 Kelvin. So that is the third scale, which is the Kelvin scale. And also, Kelvin scale, so 1 Kelvin is equivalent to 1 degree Celsius. So if there is an increase by 1 Kelvin, so we can say that there is also an increase by 1 degree Celsius. Okay? So, and since Kelvin scale is based on absolute zero, so therefore zero is the minimum value of Kelvin scale. So zero yung kanyang minimum value. So since zero yung kanyang minimum value, then there is no negative value in Kelvin scale. So since zero yung kanyang pinakamababa, so wala na siyang mas mababa pa, which is the negative value of Kelvin. Okay? So that is the difference between Kelvin and Celsius or Fahrenheit. Okay? So the last scale is the Rankine scale. Okay? So last scale is the Rankine scale, which was developed by Sir William John McKern Rankine during 1859. So Sir William John McKern Rankine developed the Rankine scale during 1859. So Rankine scale is the same with, or almost the same with, Kelvin scale, since it is also based on absolute zero. Okay, so since it is also based on absolute zero, the only difference, or the difference of Rankine scale to the Kelvin scale, is that Rankine scale is equivalent to degree Fahrenheit. Okay, so Rankine scale is equivalent to degree Fahrenheit. So kanina yung Kelvin, it is equivalent to degree Celsius. So ngayon, si Rankine, it is equivalent to degree Fahrenheit. Okay? So that is the Rankine scale. So just like the Kelvin scale, wala pa rin siyang negative value since the minimum value of Rankine scale is zero. So when we say zero Rankine, then it means there is no temperature. Okay? So those are the four scales of temperature, which is the Celsius scale, the Fahrenheit scale, the Kelvin scale, and the Rankine scale. Okay? So next is the, so after temperature, okay, so we will talk also with heat, or the, before that, let us first talk about the conversion of temperature. So we will convert temperature from a scale, okay, into another scale. So try natin to convert from one scale to another scale. So, for example, if we convert Celsius to Fahrenheit, or Fahrenheit to Celsius, or Celsius to Kelvin, or Rankine to Fahrenheit, ganon. So, conversion of temperature. So, sir, paano namin i-convert yung temperature scales? So, using these three equations, we can be able to convert temperature. So, ito yung tatlong equation na pwede nating magamit in converting temperature. So, we have here these three equations. So, ito yung tatlong equation na pwede nating magamit in converting scale. So, from degree Fahrenheit to degree Celsius and vice versa, we will use degree Fahrenheit is equal to 1.8 times degree Celsius plus 32. And next is from Kelvin to degree Celsius and vice versa, we will use Kelvin is equal to degree Celsius plus 273.15. And last is for the degree Fahrenheit to Rankine or vice versa, we will use degree Fahrenheit is equal to Rankine minus 459.67. So using these three equations, mamimili tayo dito which is applicable for the conversion of unit. So kung ano yung given and ano yung hinahanap natin, so mamimili tayo dito kung ano yung gagamitin natin na appropriate equation. Okay? So let's try to convert some temperature into another scale. So let's start first with converting 38 degrees Celsius into degree Fahrenheit. So since from Celsius to Fahrenheit siya, yung pipiliin natin is yung ano yung pwede nating magamit na equation. So based on dito sa tatlo. So since ang hinahanap natin is Fahrenheit, then ang given is Celsius. So itong first equation ang gagamitin natin. Okay? So si first equation, which is degree Fahrenheit, is equal to 1.8 times degree Celsius plus 32. So substitute lang natin ang value ng ating Celsius, 38. So 1.8 times 38 plus 32, that is equal to 100.4. So that is the conversion of 38 degrees Celsius into Fahrenheit. Okay? So next, try naman natin convert from Fahrenheit to Celsius. So since Fahrenheit and Celsius ang ating given, so gagamitin natin the same equation. So substitute lang natin ang value ng Fahrenheit, which is 86, is equal to 1.8 times degree Celsius plus 32. Okay, so lipat natin si 32 from positive, magiging negative. That is 86 minus 32. And then divide both sides by 1.8. So it is now equal to 30. So from 86 degree Fahrenheit converted to degree Celsius, that is equal to 30. Okay? So that is the conversion of unit from one scale to another scale. Okay. So next is so after temperature, we will talk also about heat. So if you can still remember, heat is the energy in transit due to temperature difference. Okay? So it is an energy transit due to temperature difference. So heat, or the SI unit for heat is the joule. So joule is the SI unit of heat. It is taken from the last name of the developer of this unit, which is Sir James Prescott Joule. So he developed the unit of heat, which is the joule. But joule is not only the unit that is being used in heat. So joule is not the only unit that is being used in heat, but it is the standard unit that is being used in heat, especially here in the Philippines. So there are some other unit which is also used. Okay, for us, we are also using the unit calorie. Okay, we are also using the unit calorie. So it is the amount needed to raise the temperature of 1 gram of water by degrees Celsius. So joule and calorie are the two common unit that is being used in heat in the Philippines. Okay, so these are the two common unit that is being used in heat. So, but the standard unit is joules. Joule talaga yung standard unit. So there are some instances where they are using calorie as the unit of heat. So sir, paano if calorie? Then ang hinahanap natin is joule. So paano namin siya i-convert? So to convert calorie to joule or vice versa, we'll use this given value. So 1 calorie is equal to 4.186 joules. So using this value, we can be able to convert calorie to joules or joules to calorie. Okay? So that is the unit for heat. There are also other unit for heat, though di siya masyadong ginagamit, especially for us. One of it is the British thermal unit. So I think hindi siya masyadong familiar, okay? Hindi siya masyadong familiar for us since hindi siya masyadong ginagamit even especially here in our country. So the British thermal unit, so commonly most of the time it is used in some industries, especially in America. So they use it. So the BTU or the British thermal unit is the amount needed to raise the temperature of 1 pound of water by 0 degree Fahrenheit. So that is the third unit of of heat. Okay, so those are the units that is being used in uh, heat or the thermal energy. Then let's proceed with the effects, okay, the effects of heat and the methods of heat transfer. Okay, so the effects of heat and the methods of heat transfer. So there are some effects of heat. So one of it is the thermal expansion, the change in temperature, and the change in phase. So these are some effects of heat, and we'll also talk about the methods of heat transfer. But today, we will only focus on the first effect of heat, which is the thermal expansion. Okay, so do you know that there are gaps on concrete road? So if mapapansin natin yung daan or yung kalsada, it has a line, okay? Has a line which somehow creates a unique design for roads, but this line is not only for design purposes, okay? So this line is not for it is not only for design purposes. So this line, okay, this line are the gaps on concrete roads. So ito yung gap ng concrete road. So if you look in this closer image, so makikita natin dito that there is really a gap between the concrete road. So ito, makikita natin dito, so there is a gap. So hindi natin siya masyadong mapapansin since maliit lang yung gap nila from one another. But there is really a gap on concrete roads. But do you know why there are gaps in concrete road? Okay? So one of the major reason of it, okay, one of the major reason of these gaps is because of the first effect of heat, which is the thermal expansion. Okay? So thermal expansion is one of the major reason kung bakit merong gap yung mga concrete road, yung kalsada. So most objects expand when heated and contract when cold. So yung object, kung ito ay paiinitan, then it will expand. So if the temperature, so kung bababa naman yung temperature, then it will contract. So ito ay liliit. So bakit siya mag-expand when heated? It is because, okay, it is because the atom, okay, the atom on the object, when the atom is being heated, okay, when an atom is being heated, the movement of the atoms will increase. So kung maiinitan yung atom, okay, bibilis ang kanyang movement. Okay? So, bibilis yung movement ng atom kung ito ay naiinitan. Okay, so, if bibilis yung movement ng atom, and we all know that the atom's position in a solid object, okay, they are in a fixed equilibrium. So, each atom even in solids where atom has a fixed equilibrium position, so yung distance ng atoms in a solid object, so masyadong maliit yung distance ng atom in a solid object. So since gumagalaw yung atom, okay, if hindi pa ito naiinitan, its movement is very minimum. So mabagal lang yung kanyang movement. But once ito ay nainitan, so once it is being heated, its movement will become faster. So bibilis yung kanyang movement. So since maliit lang yung gap or yung gap ng atom from one another, so that is the reason kung bakit mag-e-expand yung isang object. So since gumagalaw yung atom, so since mabilis yung paggalaw ng atom, so it will make the object expand. So lalaki yung object when it is being heated. It is because of the movement of the atom. When it is heated, it will become faster. So it will become faster as the atom is being heated. And that is also the reason kung bakit mag-expand yung isang object. Though, hindi natin siya mapapansin with our naked eye. So since yung expansion ng object is hindi naman siya ganun talaga kalaki, okay, so since hindi naman talaga siya ganun kalaki, so hindi natin siya mapapansin kaagad, especially using our naked eye. So that is the first effect of heat, which is the thermal expansion. So there are three types of thermal expansion. First is the linear expansion, the area expansion, and the volume expansion. So linear, area, and volume. So siguro alam naman natin siguro kung ano ang difference ng linear, area, and volume. Okay? So these are the three types of expansion. So linear expansion, it is one-dimensional. So we have delta L is equal to L sub O times alpha times the change in or the delta T. So delta L means the change in length. L sub O is the initial length. Alpha or delta T is the change in temperature. And alpha is the coefficient of thermal expansion. So there are some objects which thermal expansion or the coefficient of thermal expansion is already given. So there are some objects where the coefficient of thermal expansion were already being solved by experts. So, makikita natin to in the internet. So, there are some objects. If we search coefficient of thermal expansion, so some objects already has a value of coefficient of thermal expansion. Okay, so experts already solve the coefficient of thermal expansion of that particular object. Though hindi lahat ng object, but there are some objects who already has the coefficient of thermal expansion. And that is our alpha. For our area expansion, okay, for area expansion, we will use delta A, or the change in area, is equal to the initial area times gamma times the change in temperature. Gamma is equivalent to 2 times alpha. So, sir, bakit we multiply alpha by 2? So, since area is already two-dimensional, so that's why we also need two coefficient of thermal expansion. So, since alpha is for one dimension only, and area is two-dimensional, so kailangan din natin ng two dimension of coefficient of thermal expansion. So that's why we need to multiply it by 2. So for volume expansion naman, we'll use the change in volume is equal to the initial volume times beta times the change in temperature. So beta is equal to 3 times alpha. So 3 alpha, it is because volume is already a 3 dimension. So 3-dimensional itong volume. That's why we also need to multiply coefficient by 3. Okay? So these are the 3 types of expansion. So we have the linear expansion, the area expansion, and the volume expansion. So let's try to use this equation in a given problem. So try to read the question. Okay. So in this given example, we have two different questions. So first, how much will the length of the bar changes? So the change of length, so that is the delta L. And next is, what is the new length? What is the new length of the bar as at this temperature? When we say new length of the bar, ito yung length ng object as it was being heated, as it is being expanded. So nung nag-expand na yung object, so it has a new length. So since tumaas siya, nag-expand siya, so meron na siyang bagong length. So the new length is we use L sub F for linear, and A sub F for area, and V sub F for volume. So L sub F means the final length, so it is the new length of the bar. So to obtain the final length or the new length of the object, we will just simply add our initial length, which is the L sub O, and our change in length. Okay, so the change in length plus the initial length to be able to solve for our new length or the final length. So in this case, how much will the first question is, how much will the length of the bar changes? So before we can solve for our final length, solve muna natin si change in length. So the change in length, gamitin natin yung linear expansion equation, which is change in length is equal to L sub O, or the initial length, times alpha times the change in temperature. So the change in temperature, okay, so that is L sub O times alpha, so times the change in temperature, that is the final temperature, minus the initial temperature. So ito yung gagamitin natin to be able to solve for our change in length. So, gagamitin natin ito, which is the L sub O times alpha times the final length minus the initial length. So, ano ba yung mga given? So, we have here, the initial length of the bar is equal to 1.2500. So, ito yung kanyang initial length. Then, we also have the initial temperature, which is 20.0. Yung kanyang initial temperature, 20.0 degrees Celsius. So the coefficient of linear expansion, we have 22.5 times 10 to the power of negative 6. Ito yung ating alpha. And the temperature or the final temperature, since it increased, so the final temperature is equal to 75.0 degree Celsius. Okay? Ito yung ating final temperature. Okay, so take note, take note, the unit for our temperature is always in Celsius. So since Celsius yung ginagamit natin here in the Philippines or in Asia, so Celsius rin yung gagamitin natin for our temperature. And for our coefficient of linear expansion, the unit of our coefficient of linear expansion, we will use 1 over degree Celsius. Okay? 1 over degree Celsius. So, yan yung unit na gagamitin natin in the coefficient of linear expansion. And for our length naman, okay, the length, the volume, and the area, so, wala talaga siyang specific na unit na gagamitin. So, hindi siya specific kung anong gagamitin natin na unit. So, kung ano yung given na unit, so yun na yung gagamitin natin na unit for our length, area, and for our volume. But if in case, for the area and the volume, if hindi siya given, then magkaiba yung kanilang unit. So, if magkaiba yung unit ng kanyang dimension, so ang gagamitin natin is meters. Okay? So, that is if only magkakaiba yung dimension that is given for our area and for our volume. Pero kung hindi, given na ang ating area, volume, and our linear, then we will use the unit that is being or that is already given. Okay? So, in this case, so since meter yung ibinigay, so meter na lang din ang ating gagamitin as the unit of our aluminum bar or the length. Okay? So, okay, let's solve for letter A using the linear expansion. Okay, so change in length is equal to initial length times alpha times the change in temperature. Change in temperature is equal to final minus initial temperature. So, ang ating initial is 1.2500 meter. Ang ating alpha is 22.5 times 10 to the power of negative 6, 1 over degree Celsius. The final temperature is 75.0 degrees Celsius. And the initial is 20.0 degree Celsius. Okay? So, substitute natin ang ating temperature, 75 minus 20, that is 55. Then, multiplied by 1.25 times 22.5 times 10 to the power of negative 6. So, cancel yung Celsius. So, cancel si Celsius. Ang maiwan na lang is si meter. So, if we simplify this, we can have a value of 1.546875 times 10 to the power of negative 3. Okay, so next, since the least number of significant figure is 3, so we will round this to 3 significant figure, and that is equal to 1.55 times 10 to the power of negative 3 meters. And that is the change in length, okay, or the length of the bar as it was being changed. So that is for letter A. For letter B, what is the new length? So for the new length, or the final length, i-add lang natin yung kanyang initial at yung kanyang change in length. So ang gagamitin natin na change of length, yung kanyang exact value. Okay, yung exact value talaga. So 1.2500 meter plus 1.546875 times 10 to the power of negative 3 meters. So i-add lang natin sila. And that is equal to 1.251546,875. So since the least number of decimal place is 4, so we will round this to 4 decimal place, and that is equal to 1.2515 meter. And that is the new length of our aluminum bar. Okay? So next example, a large rod of metal has a length of 5.10 meter. Gets heated, and after some time, it attains 120 degrees Celsius. This expands the rod length to 5.1056 meter. What would be the coefficient of linear expansion of the rod given the temperature of the room is 28 degrees Celsius? Okay, so ang hinahanap natin dito is the coefficient of linear expansion. So ito yung hinahanap natin. Our given, so we have the initial length, which is 5.10 meters, that is L sub O. We also have the temperature, which is 120 degrees Celsius. So the 120 degrees Celsius, ito yung temperature niya after it was being heated. So therefore, since it is after, it is the final temperature. Next, the rod expanded up to 5.1056 meter. So since nag-expand yung rod into 5.1056 meter, so ito yung ating final length. So ito yung ating final length. Okay. So next is the temperature of the room is equal to 28 degrees Celsius. So since our object is a metal, so since metal siya, ang gagawin natin dito, so since metal ang ating object, so a metal will adapt, okay, if there is no intervention into the metal, if hindi siya, if it is not placed on some heat, so kung hindi siya pinapainit, the temperature of the metal, so it will adapt the temperature of its surrounding. So kung ano yung temperature ng surrounding niya, ito rin yung magiging temperature ng ating metal. So since the temperature of the surrounding or the room is 28 degrees Celsius, so ito rin yung magiging initial temperature ng ating metal. Okay, initial temperature. Okay, so since hinahanap natin dito is the coefficient of linear expansion, ang gagamitin natin is the linear. So change in L is equal to the initial length times alpha times the change in temperature. So change in temperature. So since wala naman tayong value ng change in length, so pwede natin siyang makuha using this equation, which is L sub F is equal to L sub O plus the change in L. So ilipat na natin si initial, magiging change in length is equal to L sub F minus the L sub O. So i-subtract lang natin si final length at si initial length para makuha natin si change in length. And that is equal to, so 5.1056 subtracted by 5.10, that is equal to 0.0001. 0.56 meters. So ito yung ating change in length. So now, with this given, pwede na nating ma-solve si coefficient of linear expansion. Okay, solve natin si coefficient. So since ating change of length is equal to 0.0056 is equal to the initial, which is 5.10 times alpha times the change in temperature, which is 120 degrees Celsius minus 28 degrees Celsius. So 120 divided minus 28, that is equal to 92 degrees Celsius. So 92 degrees Celsius. Okay, next. So 92 degrees Celsius. So simplify natin 5.10 times 92, that is equal to 469.2 meters per degree Celsius. Then divide natin both sides by 469.2. Okay, so cancel yung meters. So 0.0056 divided by 469.2, that is 1.193520887 times 10 to the power of negative 5, 1 over degree Celsius. So since the least number of significant figure is 2, so we will round this to 2 significant figure, and that is equal to 1.2 times 10 to the power of negative 5, 1 over degree Celsius. Okay, so that is the coefficient of linear expansion of the metal rod. Okay, so a solid plate of lead which has coefficient of linear expansion, which is 25 by 10 to the power of negative 6, 1 over degree Celsius, is 8 centimeter and 12 centimeter at 15 degrees Celsius. So what is the change in area and the new area of the lead plate if the temperature increases to 95 degrees Celsius? So in this case, meron tayong isang lead plate daw na may dimension na 8 centimeters and 12 centimeters. So ito yung dimension ng ating lead plate. So the coefficient or the alpha is 25 times 10 to the power of negative 6 degrees Celsius. So yung kanyang initial temperature is 15 degrees Celsius. So ito yung kanyang initial temperature. So si T sub O. Then yung kanyang final temperature is 95 degrees Celsius. So ito yung kanyang T sub F. Question is, what is the change in area and the new area of the lead plate? So let's start first with the change in area, which is the delta A. So si delta A, ang una nating hahanapin before we can solve for A sub F, which is the new area or the final area, which can be taken by adding the initial area and the change in area. So, pwede nating makuha si final area by adding the initial and the change in area. But since hindi pa natin alam yung change in area, solve muna natin yung change of area natin. Okay, so using the equation for linear expansion or the area expansion, which is A, the change of A is equal to the initial length times gamma times the delta T, where gamma is equal to 2 times A. So we can use the change of A is equal to A sub O times 2A, 2 alpha times the change in time, change in temperature. So substitute natin. So substitute natin yung kanyang, since hindi given yung kanyang initial area, so ang gagamitin natin is yung kanyang dimension. So simply multiply yung kanyang dimensions, which is 8 times 12 centimeter. So 8 centimeter times 12 centimeter. So ito yung kanyang dimension. So next is 2 times the alpha, which is 25 times 10 to the power of negative 6, 1 over degrees Celsius. Next, the change in temperature. So we have 95 degrees Celsius minus 15 degrees Celsius. So ito yung ating change in temperature. So simplify, we have 96 square centimeter times 50 times 10 to the power of negative 6 times 80. So cancel yung degrees Celsius. So simplify natin, it has a value of 0.384. So since the least number of significant figure is 1, so round this to one significant figure, and that is equal to 0.4 square centimeters. So ito yung kanyang change in area. So for the new area naman, add lang natin yung kanyang initial area at yung exact value ng kanyang change in area. So which is 0.384 square centimeter plus 96. So that is equal to 96.384 square centimeters. And that is the new area or the final area of our solid plate. Okay.